This video has been brought to you by Limitless Learning TT, a holistic learning center. In this session, we will review number 5 of the May-June 2018 Paper 2 for Pure Math Unit 1. To see more material like this, go to our website, limitlesslearningtt.com, hover over the Outreach tab and click Free Material. You can also check out our YouTube channel for additional videos. For more information about the services we offer, you can visit limitlesslearningtt.com, email us at info@limitlesslearningtt.com, or give us a call at 868-610-1532. Okay, so let's get started. So number 5, part A says, use the substitution u is equal to x to the power 4 plus 2 to determine a specific integral. So we're going to use the substitution u equals x to the power 4 plus 2 to help us solve the integral of x fourth plus 2, 4x times 4x to the power of, the 7 is on the inside, 4x to the power of 7 with respect to x. Okay, so the first thing we're going to do is utilize our u substitution. So that is u is x to the power of 4 plus 2. That also means that x to the power of 4 is the same thing as u minus 2. Okay, that also means that du dx is equal to 4x to the power of 3, and therefore du would be 4x cubed times dx. Right? So now we're going to make those substitutions in here. Alright, so first thing that it's easy to see is this is going to be replaced by u. If we split this portion up into 4x cubed times x to the power 4, then that means 4x cubed, and the dx would represent our du, and then our x fourth we know is u minus 2. So now I'm going to combine all of those things together in terms of u. So what I end up with is the integral of u, right, multiplied by x fourth, which is the same thing as u minus 2, multiplied by 4x cubed times dx gives me back my du. So now I can, I feel like I forgot something. Oh, right. Cubed. Sorry, guys. Right, so my question was integral of x fourth plus 2 to be cubed, all of that to be cubed, multiplied by 4x to the power of 7. Right, so substituting x fourth plus 2 as u, I end up with u cubed multiplied by u minus 2, represents x to the power 4, and then 4x cubed times dx is the same thing as du. Right, so now that I have everything in terms of u, I can now expand these parentheses by multiplying u cubed by u and then u cubed by negative 2 to give me the integral of u to the power 4 minus 2u cubed with respect to u. This is what I am going to be integrating. So, follow standard integration. This will be u to the power of 4 plus 1, which is 5, and then divide by the power, which is 5, minus 2u. 3 plus 1 becomes 4, divided by 4, and then always remember to have your plus c, right, because it's an indefinite integral. We can also simplify negative 2 over 4 to become negative 1/2. So putting everything back together, we get 1/5 u to the power of 5 minus 1/2 u to the power of 4 plus c. But we know what u is. U is right here. X fourth plus 2. So now I'm going to replace u with that. So I'm keeping my same power to the power 5. But u is now x fourth plus 2, right, to the power 5. And then here it is x fourth plus 2 to the power of 4 plus c. Yeah, so that is our final answer. That's part A. Part B. Calculate the area of the region lying between the parabolas y is equal to x squared and x is equal to 1/8 y squared. Okay, so the first thing that I'm going to do is actually write down the equation. So y is equal to x squared. I'm going to call this equation 1. Right, and then my second equation, which is x is equal to 1/8 y squared, is going to be equation 2. Now I can also kind of rearrange this second equation as an equation 2 to have it in terms of y, just because sometimes that's nice, right? So rearranging that equation, I multiply both sides by 8 to give me 8x is equal to y squared, and therefore that means that y is equal to the square root of 8x, right? So now I'm going to write that as another form of equation 2. That is that is y is equal to the square root of 8x. Right? Just a handy thing to note in case we need it in another form. So we want to calculate the area of the region lying between those two equations. Now it's kind of nice to have an idea of what this graph is going to look like. So just a sketch, right, to get an idea. So the graph of x squared looks like this, right, where I didn't draw it fantabulously, but where the minimum point occurs at the origin, and it also touches the x-axis. So the x-intercept and the minimum point will be the same thing, and it is 0, 0, which is the origin. And then your graph, x is equal to 1/8 times y squared, actually looks a little bit like this. Right? So, again, this is a picture of it if you knew how the graph is going to look. If you did not know how the graph is going to look as yet, when you solve the equation simultaneously, you will get an idea of, you can kind of get an idea of how the graph is shaped. Right? So what we need to do is find the 2 points of intersection, which would be this point here, and then this point here, which is most likely probably going to be the origin. Now again, this is a sketch. We will see when we actually solve the equation simultaneously whether this is true or not. Right, so we're looking to first, before we can even calculate the area of the region which is integrating, we need to be able to find the limits between which we're integrating. So this value here, let's call it x sub 2, and this value here, which is x sub 1. And so in order for us to find those two limits, we need to solve our equation simultaneously. So let's look at solving this simultaneously. I can substitute, I will want to substitute x into my equation 1. So I'm substituting equation 2 into equation 1. So basically everywhere I see x in equation 1, I'm going to replace with 1/8 y squared. So now I have that y is equal to x, which is 1/8 y squared, and that has to be squared. Alright, so y is equal to 1/8 squared is going to be 1/8 by 1/8, which is 1 over 64. And then y squared squared will be y to the power of 4. Right? Next, I'm going to multiply both sides by 64 to get rid of that denominator. So I have 64y is equal to y to the power of 4, and then I'm going to carry everything on one side. So y to the power of 4 minus 64y is equal to 0. And again, I can break this into factors, pulling out what is common, which is y, and I'll be left with y cubed minus 64. Right? So now I know that y has to be equal to 0, and that y also has to be equal to, y cubed minus 64 has to be equal to 0, which means y cubed is equal to 64, which means that y is equal to the cube root of 64. So you're looking at one number you can multiply by itself 3 times in order to get 64, and that number will be 4. So now I know that y is 0 and y is 4, and I can substitute that into my first or my second equation to solve for x. I'll substitute it into my second equation. So my second equation says x is equal to 1/8 y squared. So when y is equal to 0, 0 squared will be 0. 1/8 times 0 is 0. That means that x will be equal to 0. And then when y is equal to 4, it means x will be equal to 1/8 times 4 squared, which is 16. And so 1/8 multiplied by 16 is going to give me 2. So x is equal to 2. So now I know my points of intersection. They are 0, 0, and 2, 4. Committing that to memory, and I'm going to go back to the graph I had, right, or the little sketch I had of what your graph should look like. This is x squared. This graph here is your second equation. And okay, this is not the best. It's not the best. Sorry guys, it's not the best drawing, but bear with me. Okay, and this is right. Okay. Why is this not coming out great? Close enough, right? So this is one point of intersection and the second point of intersection, which is at the origin. So what you're going to be doing is integrating between x is 2 and x is 0. Now if we look at this up close, so what we have is a graph that looks like this on this side, and then like this. So what we really want to find is the area in between here. We can do that if we find the area under the red graph first. So area under the red graph will give me, between 2 and 0, will give me this region. What's shaded? Oh, let me not do it like that. Alright, so this here is 2 and this is 0. And so if I integrate, that is finding the area under the red curve. It's going to give me where my red dots are. Right? And if I integrate under my black curve, right, between 2 and 0, it's going to give me this area here, right? And what I really want to find is this area. And so in order to find this area, it's going to be the area under the red curve minus the area under the black curve, i.e. the area under the square root of 8x minus the area under x squared. And so that's what I'm going to use for my integral. So I'm going to be integrating between 2 and 0, because those were the points, my two x values, so my points of intersection. And I'm going to be looking at the first red graph, which is equation 2. So I'm looking at the square root of 8x minus x squared, all with respect to x. Right, so that's why it's good to draw a diagram so you can see exactly what is the region that you're looking for and how you're going to get that region by either subtracting areas or adding areas together. So now that we know what we're integrating, we can make space. And remember, the square root of 8x is the same thing as 8x to the power of 1/2. Rules of exponents or indices. Right, so I'm going to replace that here because it's going to make it easier for when I actually have to integrate. So now I'm going to integrate with respect to x, and I'm starting off with 8x to the power of 1/2 plus 1 becomes 3/2, and then I have to divide by 3/2. If you divide by a fraction 3/2, it's the same thing as multiplying by the reciprocal, which is 2/3. So times 2/3 minus x squared becomes x to the power of 2 plus 1, which is 3, divided by 3. Okay, hold up, guys. Just 1 second. This is why you always put in your parentheses. This should be 8x to the power of 1/2, right? Which is the same thing as 8 to the power of 1/2, x to the power of 1/2, right? So I just want to make that distinction. Put back my 3/2. This is 8 to the power of 1/2, and this is 2. Yeah, and so because I have a definite integral, there's no plus c, and this is going to be between the limits 2 and 0. Right, so let's start off with the first part. The good thing is that because we're doing between 2 and 0, and how the equations of how we would have gotten them, when you substitute in 0, it's actually just going to be 0. It's going to take everything to 0. So we're going to start off with 2. So that is going to be 2 times 8 to the power of 1/2, right? 2 to the power of 3/2, all over 3, minus 2 cubed over 3, and then minus, when you substitute in 0, you'll just end up with a minus 0. Right? Then now we're going to simplify, which is the fun part. Right, so this 2 is 2 to the power of 1, right, times 2 to the power of 3/2. Actually, I am going to choose to do a little bit of on this side, just so that you understand where I'm going. Rules of indices, right? 2 to the power of 3/2 is the same thing as the square root of 2 cubed. 2 cubed is the same thing as 8. So this is the square root of 8. We also know that 8 to the power of a half is the same thing as square root of 8. So if I multiply 8 to the power of a half by 2 to the power of 3 over 2, I get square root of 8 multiplied by square root of 8, which is going to get rid of the square root sign and just leave me with 8. Right, so I'm going to have 8 multiplied by 2 over 3 minus 2 cubed is the same thing as 8 over 3. And then 2 times 8 is going to give me 16. So I have 16 over 3 minus 8 over 3. My denominators are the same, so I simply subtract the numerator. 16 minus 8 will give me 8 over 3. And I'm looking for the area. Area is in square units. Right, so good to know laws of indices or exponents that will help you simplify things and make it easier. And then also it's always good to draw a diagram or a sketch so that you can see how your lines are intersecting and you're able to ascertain which areas you need to find. Okay, so that would be 5 part B. So now we're going on to 5 part C, which says the equation of a curve is given as f of x is equal to 3x to the power 4 minus 2x cubed minus 6x squared plus 6x. And so part 1 says determine f prime of x and then f double prime of x. Right, so f prime of x basically just means the first derivative. So you're differentiating once with respect to x. That's going to give you 12x to the power of 3 minus 6x squared minus 12x plus 6. And then they ask you to find f double prime, which means you're going to integrate your f prime of x one more time, right? So like the double differential. So f double prime of x is akin to d2y over dx squared. So we simply just differentiate the function right above. So this becomes 36x squared minus 12x minus 12. Right, so that part was easy. That's part C, 1 and 2. And then part 3 says, calculate the x coordinates of the stationary points of the above function, f of x, which is 3x to the power 4, minus 2x cubed, minus 6x squared plus 6x. So we need to find the stationary points, the x coordinates, and then we need to determine the nature of the stationary points. Right? Simple, because we already kind of found the information that we need. Now, first thing is stationary points occur when your first derivative, which in this case is f prime of x, is equal to 0. Right? So when your first derivative is equal to 0, you can find stationary points. So start points will occur when your first derivative, that is 12x cubed minus 6x squared minus 12x plus 6 is equal to 0. Now, the first thing that I would probably do is look to see what is in common between all of these, which is the number 6. So I would actually just divide by 6. If I divide by 6, it leaves me with 2x cubed minus x squared minus 2x plus 1 is equal to 0. And so this is a cubic polynomial, and we need to kind of break it down into factors to find out the x-intercepts. Now, the first thing that you want to do is try a number to see if it would be a root or not. So my go-to in this case will be, because I know x equals to 0 is not going to give me 0. I'm going to try x is equal to 1. So if x was equal to 1, that means I will have 2 times 1 cubed minus 1 squared minus 2 times 1 plus 1. And I need to see if that's going to give me 0. Right? So 1 cubed is 1, 2 times 1 is 2, 1 squared is 1 minus 1. Minus 2 times 1 is minus 2, and then plus 1. So everything is going to cancel. 2 minus 1 is 1, 1 minus 2 is negative 1, negative 1 plus 1 gives me 0. So that means that x plus 1 is a root, which is great. So that was nice. X equals 1 is a root, which means now I can find the rest of roots of this solution by either doing long division or doing synthetic division. I particularly like synthetic division because it's shorter and it's easier. If you don't know synthetic division, you can do the regular division of the polynomial. If you I'm going to do synthetic division. If you don't know it, hey, you learned something new today, you can pick that up. So I'm going to draw like an upside down division sign, and basically I'm writing all the coefficients of my polynomial. So that's 2 for 2x cubed, negative 1 for minus x squared, minus 2 for the x value, and 1 for my constant. And I am putting my root, which is 1, on the outside. The first thing I do is bring down this number outside, which is 2, and then I'm going to multiply this number outside by 1. 2 times 1 is 2. I place it here, and I add these together. Negative 1 plus 2 gives me 1. I repeat the same thing. 1 times 1 gives me 1. Negative 2 plus 1 is going to give me negative 1. And then negative 1 times 1 is going to give me minus 1. I add these together and I get 0, which means that there's no remainder. So when I divide by x is equal to 1, or when I divide by the factor x minus 1, what I'm going to end up with is this is my remainder, which is 0. This is my constant. This is my x value, and this is my x squared value. So what I'm going to end up getting is 2x squared plus x minus 1 is going to be what I remain with. So basically what I'm saying is that since x equals 1 is a root, it must mean that x minus 1 is a factor. So now this is my equation. X minus 1 multiplied by 2x squared plus x minus 1 is going to give me 0. And now that I have a quadratic equation, I can further break this down into 2 factors. And so the 2 factors that's going to work is 2x here and x. Right, plus 1 minus 1, right? And it needs to make sense because 2x by x will give me back 2x squared. 2x by 1 will give me plus 2x. Minus 1 by x will give me minus x. And then minus 1 by 1 will give me minus 1. This will go to plus x minus 1. So I get back my same thing. You can always do a double check just to make sure that your factors are correct. So now I have fully factorized, and this means that x is equal to 1, x is equal to 1/2, and x is equal to negative 1. Those are my x coordinates of my stationary point. So that's the first step. Now I have to determine the nature. What you use to determine the nature is this equation, your second derivative function. And so what I'm going to do to my second derivative function, I'm just going to simplify it a little bit because all of my terms have 12 in common. So I'm just going to pull out a 12. And that's going to leave me with 3x squared minus x minus 1, right? And for the second derivative, all you're doing is checking to see if the x value is going to produce a positive value. If it's positive, it means you have a minimum point. If it's negative, it means you have a maximum point. And if it's zero, it means you have a point of inflection. So if it is positive, then you have a minimum point, which looks like this. If it is negative, then you have a maximum point, which is here. And if it's zero, then you have a point of inflection, which looks like this. Right? So all we need to know is whether it is positive, negative, or zero. You don't actually need to know the value itself. So I'm going to try each of these points in my second derivative function. Right? So the first one is when x is equal to 1, f double prime of x will be equal to 12 times 3 times 1 squared minus 1 minus 1, right? 1 squared is going to be 1. 3 times 1 is 3. 3 minus 1 is 2. 2 minus 1 is 1. 12 times a positive number is positive. If it's positive, it means that x equals to 1 is going to be a minimum point. So I put that right under minimum point. Right, then I try the same thing for x is equal to a half. When x is equal to 1/2, I get f double prime of x being equal to 12 times 3 into 1/2 squared minus 1/2 minus 1. Right, 1/2 squared is the same thing as 1/4. So 3 times 1/4 will give me 3/4. 3/4 minus 1/2 is going to give me 1/4. 1/4 minus 1 is going to give me something that's negative in here. 12 times a negative number is going to be negative, which means that this is negative. And so therefore, it means that this is a maximum point. And again, I repeat this same thing for when x is equal to 1. So when x is equal to, negative 1, it means that f double prime of x will be equal to 12 into 3 times negative 1 squared minus negative 1 minus 1. Right, so this is 12 into negative 1 squared is 1 times 3 is 3. 3 minus a negative number becomes plus 1, which is 4. 4 minus 1 becomes positive. 12 times a positive number is positive. So that means that this is a minimum point. Yeah. So now I have done everything my question asked, which is calculate the x coordinates of the stationary points. I did. They are x is equal to negative 1, x is equal to 1/2, and x is equal to 1. And then find the nature of each of those points. When x is 1, it's a minimum point. When x is 1/2, it's a maximum point. And when x is negative 1, it's going to be a minimum point. Right, so that brings us to the end of number 5. This is number 5 on the May-June 2018 paper 2 for Pure Math Unit 1. This session was brought to you by Limitless Learning TT, which is a holistic learning center. If you're looking for more information or more material like this, you can check out our website. Go to Limitless Learning TT, hover over the icon that says outreach and click on free material. You can check out our videos on YouTube. If you're interested in taking our exam crash courses, be sure to check out our website for details on that. And you can also send us an email at info@limitlesslearningtt.com, or you can give us a call at 868-610-1532. Thanks, guys.